This is the lecture number 6 for the linear equation 2 variable of class 10th, and we're discussing the third exercise, and we're discussing the question number 3. I think we have done up to fifth part of question number 3. In the sixth part of this question, it is given that after 5 years the age of Jacob is 3 times the age of his son, and 5 years ago the age of Jacob is 7 times the age of his son. So let the present age of the Jacob be x years and the present age of the son be y years. You have to let it. So after 5 years the age of Jacob will be x plus 5 and the age of his son will be y plus 5. You have to add 5 to get the age, their age after 5 years, and it is given that after 5 years the age of Jacob will be 3 times the age of his son. So x plus 5 is equal to 3, y plus 5. Arrange this equation. I am getting x minus 3, y is equal to 10. And it is given that 5 years ago that the age of the Jacob is 7 times the age of his son. So 5 years ago the age of Jacob will be x minus 5 and the age of his son will be y minus 5. And it is given that the Jacob is 7 times the age of his son. So bracket, open the bracket, arrange it. I am getting this equation x minus 7y is equal to minus 30. Solve this equation by substitution method. I have taken the value of x from the 1, that is 3y plus 10, and put in the second and getting the value of y as 10. When I put the value of y as 10 in this, I am getting the value of x as 40. So the age of Jacob is 40 years and the age of his son is 10 years. Now after that there is another method to solve linear equation in 2 variable, which is known as the elimination method. Now what is the elimination method? Elimination method is that in the 2 equation you multiply the 2 equation by that number so that the coefficient of one variable of both the equations should become same, and by adding or subtracting you eliminate one of the variable to obtain the value of the second variable, and you put the value of the variable you have to find, the variable you have find in the first step. When you put in the either of the 2 equations, you will get the value of the second variable. Now these are the steps in the elimination method. Multiply both the equation by the same suitable non-zero constant to make the coefficient of the one variable, either x or y, numerically equal. You have to multiply by that number so that the numerical value of both x and y should become equal. Then you have to either add or subtract one of the equation from the other to obtain the value of the one variable, or one variable is get eliminated when you add or subtract. Now solve the remaining resulting equation in one variable or x or y so that you obtain its value. Now you substitute that value in any of the either equation, any one of the equation, to get the other variable. Now this exercise 3.4 is based on this elimination method. Now question number 1, I am taking the fourth part. It is in the fraction. First of all, you remove this fraction by taking the LCM. Coefficients are in the fraction. The LCM is 6. So it will be 3x plus 4y is equal to minus 6 is the first equation. Again in fraction here, the 3x minus y is equal to 9 is the second equation. Now this is the 2 equations we have. Now we don't have to multiply any number by any number, because already we are getting the coefficient of x in both the equation is same. So you don't have to multiply by any number. So I am getting this equation. Now if we subtract the second equation from first, for subtracting you have to change the sign of the second equation. This is plus, change into minus, put in the bracket. This is plus, change into plus. This is plus, change into y. Subtracted, the x will be eliminated. That is why it is known as the elimination method. 4y plus 1 by 5y, minus 6 minus 9 is minus 15. So the value of y is minus 3. Put in either of the equation this or this. I am putting the value of y as minus 3 here, or either I put it here. So the value of x is equal to 2 is coming out to be. In this we don't have to multiply any equation by any non-zero real number, because already the coefficient of x in both the equations are same. Simply have to subtract or add to get the value of the one of the variable and put in the other to get the second variable. Now again we have the word problem, question number 2. You do have to do the remaining part of question number by yourself by elimination method. In question number 2 first part, we have It is given that there is a fraction. If you add 1 to the numerator and subtract 1 from the denominator, the fraction is 1. And when you add only 1 to the denominator, the fraction is 1 upon 2. So I've let the fraction be x upon y. So when we add 1 to the numerator, that is x plus 1, and subtract 1 from the denominator, that is y minus 1, the fraction is coming out to be 1. Cross multiply, x minus y is equal to minus 2 will be the equation. Now when we add 1 to the denominator, the fraction is becoming to be 1 upon 2. So x upon y plus 1 is equal to 1 upon 2. Cross multiply and arrange, we are getting these two equations. So the equation is x minus y is equal to minus 2, 2x minus y is equal to 1. Now again in this equation we don't have to multiply by any number because the coefficient of y is same here. Y coefficient is same here. So you simply change the sign because this is negative. Minus plus minus, this will be cancelled out. That is the y is eliminated here. So minus 2x plus x, it will be minus x, minus 1, minus 2, it is minus 3. The value of x is 3. Put in either this or either in this or this, you are getting the y as 5. The fraction is 3 upon 5. So this is the easy question. In question number 2, second part, it is given that the 5 years ago, the age of Noori is 3 times the age of Sonu. And after 10 years, the age of Noori is 2 times the age of Sonu. So let the present age of Noori be x years and the present age of Sonu be y years. And 5 years ago, subtract 5 from both the ages. That is x minus 5, y minus 5. And it is given that the age of Noori is 3 times the age of his age of Sonu. Open the bracket, arrange it. I am getting x minus 3y is equal to minus 10. And after 10 years, add 10 to both the present ages of Noori and Sonu, that is x plus 10, y plus 10. And it is given the age of Noori is 2 times the age of Sonu. Open the bracket, arrange it. You are getting the second equation. Again, in this question also, the coefficient is already same of x. So you simply have to subtract the second equation from first. Minus plus minus, plus and minus, it is become plus, it is plus become minus, it is plus become minus. So this will be eliminated. Minus 3y plus 2y equal to minus y, minus 10, minus 10, minus 20. The value of y is coming out to be 20. Put the value of y 20 either in this or this. You will get the value of x as 50. So the age of Noori is 50 years and the age of Sonu is 20 years. So somewhat easy question is this. This is the elimination method, and we have done some questions, word problem based on this elimination method. Now in question number 2, third part, see it very carefully. There's a 2-digit number is given, and it is given that the sum of the digit of the 2-digit number is 9, and it is given that the 9 times this number is 2 times the number obtained by reversing the order of the digits. So be very careful. Whenever you have to take a 2-digit number, you always take the number as 10x plus y. Now why you have to take the 2-digit number as 10x plus y? Because well, suppose we have the number 26. So how you have to write it? You have to write it 2 into 10 plus 6. That is, whenever you have to 2-digit number, the 10 place number is multiplied by 10 and plus unit place number. So let the 2-digit number be 10x plus y. It means the unit place digit is 10 and the unit place digit is y and the 10 place digit is 10x here. So let the 2-digit number be 10x plus y. Unit place y, 10 place x. So you multiply the 10 place digit by 10 and add to the unit place. Now by reversing the order of the digit, the number will become 10y plus x. Means the unit place becomes 10 place and 10 place become unit place. As we have done is here, 26 I have taken, the unit place is 26, 10 place is 2. Now if we reverse the order, it becomes 62. So 10 place will become 6. So in this, it will become reversing the digit 10y plus x. So original number by reversing the order of the digit, we have obtained 10y plus x. So in the first case, it is given that the sum of the digit is 9, that is x plus y is equal to 9, and it is given that 9 times the number, that is 9, 10x plus y is the original number, is equal to 2 times the number obtained by reversing the order of the digit, that is 10y plus x. So open the bracket, arrange it, I am getting the equation 2 as this. Now this is the first equation, this is the second equation. Again by chance in this the coefficient of y is already same and the sign of both the y is also different, so you have to simply add it. You don't have to change the sign also. So adding these two equation, I'm getting 9x 0, this is 9, so x is coming out to be 1. Put the value of x in either this or this, you are getting the value of y as 8. The number is 10x plus y, to replace the value of x as 1, y as 8. The number coming out to be 18. So the 2-digit number is 18, and if we reverse it, it becomes 81. And the sum of the digit is 9 here. The 1 plus 8 is 9, the digit sum is 9. Now in the fourth part of this question, it is given that there is two types of notes, and it is given that the total number of notes is 25 and the total value of those notes is 2000. The total value of those notes is 20. So let the 50 rupee notes be x and the 100 rupee notes be y. Number of 50 rupees notes be x and number of 100 rupees note be y. So it is given that x plus y is equal to 25. The total is 25. The total number is 25. Now it is given that their total value is 2000. So the total value of 50 rupee notes will be 50x and the total value 100 rupees note will be 100y. So 50x plus 100y is the total value of the notes, which is equal to 2000. Now you can divide the whole equation by 50 to make it simple. So it comes out to be x plus 2y is equal to 40. Again by chance I am getting the two equation in which one of the variable already same, that is x and x. Now the change the sign of all the terms of the second equation, minus x minus 2y minus 40. X will be eliminated, y minus 2y will be equal to minus y, 25 minus 40 will be minus 15, the value of y is 15. Put this value of y in either 1 or 2, you'll get the value of x as 10. So the value the number of 50 rupee notes is 10 and the value of 100 rupee note is 15. Oh sorry, the number of 100 rupees note is 15. Now in fifth part of this question, it is given that there's for lending or borrowing a book from the library, there's a fixed charge for 3 days. Fixed charge for 3 days, and after that there's a charge per day. A person had borrowed a book from a library and he pays rupees 27 and for 7 days, and another person have borrowed a book and for 5 days he has paid rupees 21. So you have to tell the fixed charges for 3 days and the charge per day for the book. So I've let the charge for fixed charge for 3 days rupees x and the fixed charge per day for the book is rupees y. So in the first case for the 7 days the charge will be only for 4 days because x rupees is for the 3 days. So out of 7, 3 days charges rupees x and the charge for remaining 4 days will be 4y. So it's coming out to 27, and similarly for 5 days he paying rupees 21. So it means he is paying for 3 days rupees x and for the remaining 2 days he will pay for rupees 2y because charge per day is rupees y. For the 5 days, 3 days charge is x and for the remaining 2 days 2y, and the total he is paying is 21. So this is the two equation. You solve them by elimination method and you will get the value of x and y. We will discuss the third algebraical method in the next lecture. Thank you.